As scientists have done experiments and learned more and more about atoms, they've changed the way they think about atoms. So in this video, we're going to look at a timeline of the different ways that scientists have pictured or imagined atoms over the years. Now, the first people to really talk about the idea of atoms were the ancient Greek philosopher Democritus and his teacher Leucippus. They lived about 2,500 years ago. And Democritus, he said something like this. He said, imagine you have an object, like say a slice of bread, and you cut that in half. And then you take half of that and you cut it in half. And then you take half of that and you get the idea. Eventually, he said, you're going to come to something that you can't cut in half anymore. And he called these objects, he called them atomos, which means uncuttable, and it's where we get the word atom from. Democritus imagined that all matter, all stuff, was made of these tiny, uncuttable particles. And he imagined that the atoms came in different sizes and different shapes. He imagined, for example, that iron atoms had hooks, which is how they could hold together so strongly. And he thought that salt atoms had spikes on them because he felt that salt tasted sharp. So, Democritus was right. But people didn't really take to his ideas. Part of the reason was because around the same time, the well-known philosopher Aristotle proposed his own idea of what matter was made of. He said that different things were made of different amounts of the elements earth, water, air, fire, and ether. This is kind of like Captain Planet if you're old enough to get that reference. And more people believed Aristotle, maybe just because he was so popular already. So Democritus and Leucippus, they were right all along. But here's the thing. They weren't scientists. They couldn't do experiments in the laboratory to prove that they were right. And because of this, some people think that their idea, it was just kind of a lucky guess. They couldn't actually prove what they thought. So, how can you tell whether it's right or wrong? Ideas about atoms remained that way for about 2,000 years. Until in 1808, the British chemist John Dalton came up with the first scientific experiments that showed that matter was made of tiny little particles. This is kind of how John Dalton pictured atoms. He imagined them sort of as tiny little balls that arranged in different combinations to make different things. And he imagined that these atoms were indivisible. You couldn't cut them into smaller pieces. Now, at first, nobody believed Dalton. But over the course of the 1800s, more and more scientists did begin to believe what he had to say. But then in the 1900s, the early 1900s, people's idea about atoms started to change. One of the key things that caused this change was that in the late 1800s, J.J. Thomson discovered that atoms have electrons. And he discovered that electrons are much, much smaller than atoms. So while Dalton thought that atoms were tiny and indivisible, J.J. Thomson said, no, they're not indivisible because they're made up of electrons, which are much smaller. So J.J. Thomson pictured the atom as sort of like a blueberry muffin. He called this the plum pudding model. J.J. Thomson imagined that if you took an atom and split it open, you'd see tiny electrons stuck throughout the inside of it, just the way blueberries are stuck in the dough of a blueberry muffin. And Thomson thought that what's the dough in a blueberry muffin? That it was like a positively charged substance. So you had negative electrons stuck in like a positively charged dough. And together, the positive and negative charge balanced, the two things balanced each other out so that the atom was electrically neutral. But the big change from Dalton's model to Thomson's model was showing that atoms weren't actually indivisible, that they were made of even smaller things. Now, not too much longer, in the gold foil experiment, Ernest Rutherford discovered that atoms had a nucleus, that all the positive charge in an atom was concentrated right in its center, and that besides that and the electrons, atoms were pretty much empty space. So J.J. Thomson thought the positive charge was all distributed throughout, like dough in a muffin, but Rutherford showed that all this positive stuff was concentrated right here in the center. And this is what we call the nuclear model of the atom because it has a nucleus. Sometimes people call this the Rutherford model. Now, so far we've been talking a lot about the positive charge and the nucleus of an atom. But we haven't talked too much about what's actually going on with these electrons in the atom. And in 1913, the physicist Niels Bohr came up with his model of the atom. He reasoned that there was a nucleus in the middle, just like Rutherford had, but that electrons, instead of just sort of being randomly distributed throughout the atom, Bohr said that the electrons were sort of like planets around a sun, that they were spinning around the nucleus in circular orbits. So here are a picture of some of the electrons, and here are the orbits. Imagine that they're spinning around the nucleus in these circles. All right, now, people thought Bohr's idea for the electrons made a lot of sense at first, but then in the 1920s, additional experiments showed that it wasn't exactly the way electrons really move. And a variety of physicists, particularly the physicist Erwin Schrödinger, showed that electrons weren't really spinning in orbits, but it's more like they were hyperactive flies, and they were buzzing around the atom, sketching out different shapes. It's kind of if you did like time-lapse photography on a hyperactive fly, and you saw that over a long period of time it sketched out a particular design. And whereas Bohr called these circular paths, he called them orbits, Schrödinger called the hyperactive sketch-out shapes, he called them orbitals. Here's a circular orbital too, but electrons didn't only make circles. This is actually a sphere because it's a circle in 3 dimensions. Here is another shape, another type of orbital that electrons could also make. Looks like this, sort of 2 teardrops next to each other. So in the quantum mechanical model, electrons don't orbit the nucleus, they buzz around the atom, sketching out different shapes. Now let's focus on the nucleus here. Over the same amount of time, and a little bit later, scientists were discovering the 2 subatomic particles that make up the nucleus. So we can refine this picture a little bit more. In 1919, Ernest Rutherford discovered protons, there they are, and then in 1932, James Chadwick discovered neutrons. So the really correct view of the quantum mechanical model shows the orbitals being sketched out by the electrons, but then also shows the subatomic particles, protons and neutrons here in the nucleus. Now, this is pretty much how we think about atoms today. But as scientists learn more and more about atoms, as they do more experiments, they're going to find that this model isn't exactly a perfect representation of what atoms are really like, and they're quite likely to change this and refine it even more. Now, as I said, this quantum mechanical model is like the really accurate way to describe atoms. But the thing is with these orbitals, it can really be kind of a pain sometimes to describe simple things that atoms are doing using electron orbitals. And so a lot of times in these videos, when I talk about atoms, I'm actually going to be sort of using a cross between the very correct quantum mechanical model and the sort of outdated Bohr model. Just because for our purposes, a lot of the simple things we're going to be talking about, the Bohr model, it works just fine. So already you've probably seen me draw atoms like this, where you see the electron orbits at different angles. And sometimes, particularly when we're talking about bonding, we're going to be drawing atoms like this, with the protons and neutrons here in the nucleus, and then electrons in different rings, different orbits on the outside of the atom. We're going to find that thinking about the atom like this is very useful for simple tasks, talking about bonding and stuff. But keep in mind that when we're discussing atoms, they actually aren't exactly like this, and they're much more like the quantum mechanical model. So keep in mind that I'm lying to you a little bit, but I'm lying to you in order to make it easier to convey some fundamental topics. Here's an atom. What's the atomic number, the mass number, and net charge of this atom? So atomic number is the number of protons. In this diagram, these little red circles are representing protons here in the nucleus. So I've got 1, 2, 3, 4, 5, which means that my atomic number is 5. That was easy enough. Mass number is the number of protons plus the number of neutrons, which are these things in blue. So the mass number is 1, 2, 3, 4, 5, 6, 7, 8 protons plus neutrons. So mass number is 8. Sometimes people think you have to have the same number of protons and neutrons in the nucleus of an atom. Definitely not true. They can differ quite a bit. The net charge is how the protons and electrons balance each other out. So electrons are represented by these things here flying around the outside of the atom. 1, 2, 3, 4. 4 electrons, E minus is a way that we can abbreviate electron, and 1, 2, 3, 4, 5 P plus protons. So the protons and electrons don't quite balance out. There is one more proton than electron. So that one extra proton is going to give me a net charge of 1 plus, because each proton has a positive charge. I have one extra proton. Net charge of 1 plus. This is kind of a basic problem. Now we'll move on to stuff that's a little trickier. So here we've got an atom with this atomic number, this mass number, and net charge. From this information, we need to figure out the protons, neutrons, and electrons that are in this atom. Protons, that is going to be easy because protons, number of protons, is the same thing as atomic number, so that's going to be 7. Now what about neutrons? Mass number is protons plus neutrons. So this 15 here is protons and neutrons together. I already know how many protons there are, so I can do protons plus neutrons, the mass number, minus the number of protons equals 8, the number of neutrons. Net charge here is plus 2. If I have a positive net charge with a certain number, that's telling me how many more protons I have than electrons. So in this case, net charge of plus 2, there are 2 more protons than electrons. Since I have 7 protons, that means that I have to have 5 electrons for me to get a 2 plus charge. Here's a table with various characteristics of a certain atom. We need to fill in the things that are empty. Okay, we don't know how many protons, we don't know how many neutrons. Where can we start? Okay, we know the electrons and we know the net charge. So based on the number of electrons and the net charge that this atom has, we can figure out how many protons there are. Okay, since this is a net charge of -3, that means that there are 3 more electrons than protons, because electrons have a negative charge. So I have 7 electrons. That means that I'm going to have, if I have 10 electrons, that means that I'm going to have 7 protons. 3 more electrons will give me -3. Okay, now I know that my atomic number is the same as my number of protons, so that is also going to be 7. The mass number here is the number of protons plus the number of neutrons. So to get just the number of neutrons, I take the mass number, protons plus neutrons, minus the number of protons, 7, and that is going to give me 9 neutrons. Sometimes these table problems can be the hardest, so we'll do one more example. Here we want to find the electrons, protons, and the atomic number. We know the neutrons, the mass number, and the net charge. Okay, Let's start with protons. We know the mass number, protons plus neutrons, and we know the number of neutrons. So that means that we can take 25, which is protons plus neutrons, and subtract the number of neutrons. 25 minus 11 is going to give us 14, and that's the number of protons alone. Atomic number is just another word for the protons, so these both are going to be 14. Now that we know the number of protons in the nucleus, we can use the net charge to figure out the number of electrons. So it's a net charge of +1, which means that there should be one more proton, because I have a positive charge, one more proton than electron. So 14 protons. That means that total, I'm going to have 13 electrons. So now that you know how to solve problems like this, you're ready to go on to the videos about isotopes. Okay, what's an ion? People talk about ions all the time in chemistry. So what are they? Well, an ion is an atom or a group of atoms that have an electrical charge. Okay, that's all it is. Now, how does this happen, though? Well, inside atoms, there are two things that have an electrical charge. There are protons that have a positive charge and electrons that have a negative charge. A lot of times in atoms, the number of protons is equal to the number of electrons. So the charges balance out and you don't have any total charge. But sometimes an atom can gain or lose electrons so that it gets more or fewer electrons and protons, and then the numbers don't balance out anymore, and it's left with more negative charge because it has more electrons, or it's left with more positive charge because it has more protons. Let me give you a couple examples of how this happens. Let's look at the atom sodium. Sometimes when I'm talking about atoms, I'll just draw them as the element name inside a circle to indicate that that's the atom I'm talking about. But for our purposes, we're going to want to zoom in a little bit more. Here I've drawn two things in this zoomed in version of the atom. I got protons here in the nucleus in red, and then flying around on the outside, I have these electrons, which I've drawn as black dots. If you know a lot about atoms, you might know that I've left out the neutrons, which also live in the nucleus. But it's no big deal because neutrons don't have a charge at all. They're neutral, so they're not important for what we're talking about here. Anyway, right now, sodium has, if we counted them, 11 protons here in the nucleus, and it has 11 electrons flying around outside. So the number of protons equals the number of electrons, which means that my total net charge is 0. They cancel each other out. And so something that has no net charge, like this sodium atom, we call it neutral. Okay? But here's what can happen in sodium. You see this electron right here? It can lose this electron. It can lose it, and it flies off and usually goes into another atom. So let's look at what happens when this electron here gets lost. And now we're going to end up with a sodium atom that has 11 protons, just like it did before. But now because it's lost this electron, it used to be here, that was here, now it's not here anymore. Now it only has 10 electrons. So now the positive and negative charges don't balance out anymore, and I'm left with more positive charge than negative charge. So this thing now is going to have a charge of +1, one more positive charge and negative charge. And so I can write this, if I want to talk about the atom, I can write it as Na plus to show that it has a positive charge, whereas this, when I'm talking about a neutral atom, I'll probably just write Na. So Na plus here is an example of an ion. It's an atom that has a charge, and it's a specific type of atom. We have a name for this. We call it a cation, which is what we call an atom, an ion, what we call any ion that has a positive charge. Okay? Let me show you another example. Okay, so here's an atom of oxygen. The atom that I've drawn here has 8 protons here in the nucleus, and it has 8 electrons outside. So we have the same number of protons and electrons, which means that the total charges balance out. The plus and the minus balance out. So I have a net charge of 0, and I can say that my oxygen atom is neutral. It has no net charge. But oxygen can gain or lose electrons, and actually it really likes to gain 2 electrons. And here's a picture of the oxygen atom after it's gained 2 electrons. And now it still has 8 protons in the nucleus. And if I count up these electrons, it now has 10 electrons instead of 8, which it had before. So now the protons and electrons don't balance out anymore, and I have more negative charge than I have positive charge. I've got 2 more electrons and protons, so that means that my total net charge is going to be 2 minus. I can write the symbol for this ion as O2 minus to show that it has a 2 minus charge, whereas this neutral guy over here, I can just write O. This is an ion because it has a charge, and there's a specific name for it. We can call this an anion, which is the word that we use to describe a negatively charged ion that has more electrons and protons. Okay, here's just a little bit of vocabulary for review. So an ion is an atom or a group of atoms that have a charge. Okay, now it's possible for an atom to be neutral, which means it has no charge, means it's not an ion. But if something is an ion, it can be either a cation, which is what we call a positive ion, or it can be an anion, which is a negative ion. Here's a way that I use to remember this, okay? Anion, I think of this as standing for a negative ion, okay? And then cation, you can remember this, it's really cheesy, but you can remember this because cats have pos, and a cation is positive. All right, you'll never forget it. I swear, you'll never forget it. Okay, there's one more thing that I want to mention. I've said that an ion is an atom or a group of atoms with a charge. I haven't said anything yet about the group of atoms. So more than one atom can come together, they can stick together and form a group or a clump, and then that whole clump of atoms has a charge. When this happens, we call it a polyatomic ion, a group of atoms that have a charge. Poly means many, and atomic, so you have many atoms together that form an ion. I'll talk about polyatomic ions in future videos, so you want to check those out if you need to learn more about polyatomics. Anyway, just to review what we've learned. We learned that an ion is an atom or a group of atoms that have a charge, and something gets a charge when the number of protons and electrons don't balance out. You have more protons than electrons, you'll have an ion with a positive charge, you call it a cation. You have more electrons than protons, you have an ion with a negative charge, and you call that an anion.